Morning all. Welcome to the lecture 6 of module 1 in database management system. So today's topic we are going to discuss is three schema architecture. So before going into the concept of three schema architecture, let us discuss the terms, some few terms which are schema, instances and database state. So what is a schema? So schema we have already seen before. Schema is nothing but description of the database, which means that it is not dealing with the data, it is dealing with the type of data that we can store. Okay, the description of the database, what are the data types it can store, what are the attributes, what is the entity name, what is the table name. So all those things are called schema. Okay, so that is what we are it is saying, that description of the database. So schema is nothing but description of the database. Okay, that is called a database schema. So which is specified during the database design. So when we are going to implement the schema, we are defining the schema during the design of the database and is not expected to change frequently. Okay, so in a database, the database schema will not change frequently. Okay, once the database schema is fixed, it must be fixed compulsorily. If we want to change, we can change. That is another thing. We can change it, but it will not be changed frequently. Okay, like the data that is stored in the database, data in the database will be changing frequently. Okay, in that manner, the database schema will not change. Okay, so the frequency of changing the database schema is not very often. Okay, so this is the concept of database schema. So this database schema is represented using a schema diagram. Okay, so database schema is actually represented using a schema diagram. So this is a schema diagram. See here. So here it is given just the details of the table, the details of the database student. Okay, and its attributes. Okay, here they have not itself, they have not even given the data type also. Okay, they just given the entity name and the attributes present in that particular entity. Okay, the student database or student table is having the attributes name, student number, class, major, course. This is another database or table which is having the attributes course name, course number, credit hours, department. Prerequisite is having attributes course number and prerequisite number. So this is a representation for a schema diagram. Okay, so the schema diagram is actually representing the database schema. Okay, this database schema is actually represented using a schema diagram. Okay, so schema is nothing but description of the database. Clear? Now next concept is database state. So database state is actually the data that is stored in the database at a particular time. That is called database state. Okay, at a particular instant, for example in the student database, student table, this is the data that is captured at a particular instant. So this data may change at a particular instant or a particular time. This is the data. Okay, this also can be also called snapshot. Okay, we have take the snapshot of certain concepts and all. Okay, similarly that concept may change. Okay, but this is the snapshot of the particular time or particular instant or a particular moment. Clear? So this is called database state. So the data in the database at a particular moment in time is called database state, or it is also called snapshot. Okay, now database instance is also the same thing. Okay, database instance is the snapshot of the database at a particular moment. The same concept. Database instance is also the same. Instance is the snapshot of the database. This is the snapshot of the database at a particular moment. Clear? So the database state and the database instance are almost the same. Clear? So this is the concept of database schema, instances and database state. Okay. Now we can move on to our three schema architecture. Now let us discuss the three schema architecture. So what is the purpose of implementing this three schema architecture? So this three schema architecture is actually implemented to achieve the characteristics of database approach. So what are the characteristics of database approach? We have already discussed. which is the first point is the self-describing nature of the database. The second point is the insulation between program data and data abstraction. Third one is about multiple views, and the fourth one is about multiple transaction. So these are the characteristics of database approach. So the three schema architecture, it is actually implemented to achieve those concepts. Okay, so this three schema architecture is classified into three different level. The first one is the internal level. We actually consider it from the bottom. Okay, so this is the first level, second and third. So first level is the internal level, this is the conceptual level, and the third one is the external level. So this internal level is implemented using certain internal schema. In order to implement this internal level, we are having certain internal schema. Okay. Similarly, the conceptual level, which is also implemented using certain conceptual schema. External level is also implemented using certain external concepts or external view. Okay. Now, what is this internal level? What does it mean? Internal level means it is describing about how to store data. It is not concerned about what data we are going to store. This is implementing the concept of how we are going to store the data. That is called internal level. Okay, so internal level is actually implemented using internal schema. So this concept is actually uses a particular data model. Which one is that? The low level or the physical data model. We have already discussed about the low level or physical data model. Okay, so physical data model or low level model, we have already when we studied about the data model, what is low level or physical data model? Physical data model means that it shows only the internal representation, that is how we can store the data in a database. So those concept is actually implemented in low or physical data model. So this internal level uses the concept of physical or low level model. Okay, I'll just note it down. So this internal level make use of low level or physical level. Okay, low level data model. Okay, now the conceptual level. What is conceptual level? Conceptual level means that it deals with what data we are going to store, what type of data we are going to store. What do you mean by that? What data means the type of the data structure. Okay, type of the database. Type of the data type. What data we are going to store in the database. That is type, its constraints, its attributes, its entities, relationship, and so on. So all those concepts are actually implemented in the conceptual level. These conceptual levels are using certain conceptual schema to implement these concepts. Okay. So this conceptual level, it uses which data model? Which uses representational data model. Okay. So representational data model. Okay. Representational data model. Clear? Now the third level. Okay, third level. This is the third level, external level. So external level, it is actually concerned with the user's perspective. How a user view a database, or how a user can view, how a user can use a database. Or else we can also say that it describes the part of the database. A part of the database a particular user is interested. Okay, the part of the database a particular user uses. Okay, that is called external level. It is also called view level. Okay, it is also called view level. So this concept, it uses which data model? Which uses high level. Okay, high level data model. High level data model. Okay, so three different data models we have already studied. What are they? Low level data model, low level representational model, low level data model, representational model, and a high level data model. Okay, so low level it is also called physical model. Clear? So this physical model application is implemented in this internal level. Representational model application is implemented in conceptual level, and the high level concept is implemented in external level. Clear? So all these concepts we will be discussing in detail. So first we can see what is just given an introduction to three schema architecture. So this architecture is proposed to achieve the characteristics of database approach. As I have said that already said about the it proposed to achieve the characteristics of database approach. Okay, the goal of the three schema architecture is to separate the user applications and the physical database. So this concept is actually implemented as an interface. This main goal is to have an interface between, or a separation between, a user and the database. Look at here. So this is the database and this is the user. So how a user can interact with a database, okay, that is explained in the three schema architecture. Okay, so this is an architecture to separate user and the physical database. Clear? From the figure itself we can understand. Okay, so end user is here, database is here. So this provides a separation between, or an interface between, a user and a database. Clear? In this architecture the scheme is defined in following three levels. Okay, I have already explained it. The three levels. First one is external level, conceptual level, internal level. Okay, explanation we started from the lower level, internal level, conceptual level, and then the external level. Clear? Now let us discuss each of these levels in detail. Internal level. So this is the internal level. This is the internal level. Internal level is having certain internal schema. Okay. So it uses which one? It uses low level or physical data model. So internal level uses the concept of which model? Low level or physical data model, that we have already discussed. Okay, so this internal level uses the concept of low level or physical data model. It is the first point you have to give. It has an internal schema. So how this internal level is implemented? Internal level is implemented using an internal schema. Internal schema. So it has an internal schema which describes the physical storage structure of the database. So this internal schema, what does it describe? What does it tell? It describes the physical storage structure of the database. What do you mean by physical storage structure? This physical storage structure means how a data is stored in the database. That is called a physical storage structure. Okay, so description of a physical storage structure means how we can store a data in a database. Okay, so what all the informations will be required for that purpose? We will be requiring various types of information like storage space allocation, record description of the storage, record placement, data encryption or decryption. So these are the main concepts we'll be requiring for the concept of how data is stored in the database. Okay, in order to store data in the database, the internal level needs to deal with all these four things. Okay, storage space allocation, whether we have the required space for storing the data or not. Okay, so storage space for space allocation for data and indexes. Okay, one more point is here. It is hidden from this. It is hidden under this figure. Data and indexes, it is also there. Okay, so storage space for, we are allocating storage space for data as well as the indexes. What do you mean by index? We have already discussed about indexing. Indexing is a mechanism to easily access the data. Okay, similarly we are accessing our contents from the book using the index. Okay, similar to that, we are having an index in the data structure, database also, for easily accessing the data. Okay, so the concept is storage space allocation for data and indexes. Next is record description for storage. Okay, what type of record we are going to store? Okay, where we can store this, where we can place this record. Okay, record means the particular field or particular data. Okay, if it is a relational model, or it is an entity relation model, or if we are storing the tables in the form of a if we are storing the data in the form of a table, the rows represent the record. Okay, so record description of the for the storage. Third one is record placement. So where we can store this record. Okay, those concepts. Next is data encryption and data decryption. What do you mean by data encryption and data decryption? Suppose if we want to hide, or if we want to protect our data from an unauthorized person, we can encrypt that data. Okay, and the authorized person can decrypt the data from this encrypted information. Okay, so such type of data encryption and decryption is also performed at the internal level. Okay, so this is the first level, the base level. Okay, this internal level is actually directly contacting with the database. Okay, so what are the points we have to mention here? First point we have to mention here is this internal level is using which data model? The low level or physical data model. It using the low level or physical data model. Okay, now this internal level is implemented using certain internal schema. Okay, what does this schema contains? The schema contains the physical storage structure. It describes the physical storage structure of the database. What do you mean by physical storage structure? How a data can be stored in the database. That is called a physical storage structure. Okay, so this level describes how data can be stored in the database. Okay, so it deals with the data structure and file organization used to store data on the storage device. Okay, for implementing this concept, it will be using many data structures and file organization methods. Okay. Instead of writing this, you can directly write this one. So what are the things that the internal level need to be considered? The storage space allocation for data and indexes, record description, record placement, data encryption and decryption. Okay, this is called internal level. Clear? Second one is the conceptual level. Okay, the second level is the conceptual level. The conceptual level is implemented using certain conceptual schema, right? So this conceptual level uses which data model? It uses representational or implementational data model. Okay, so it uses representational or implementation data model. Clear? So what is this representation or implementation data model? In that model, they are describing the structure of the database. That is the what type of data we can store, the type of data types. Okay, for example, we are storing the student database. We are storing student name, student roll number, marks. Okay, student name is having the data type character. Student marks is having the data type integer. Student roll number is having the data type integer. Okay, and so on. So those are called the structure of the database. Okay. So conceptual level is actually concerned with those things, the structure of the database. Okay. In conceptual level has the conceptual schema which describes the structure of the whole database for users. It hides the details of the physical storage structure and concentrates on the describing entities, data types, relationship, user operations and constraints. Okay, so here this conceptual level does not need to implement or does not need the details of the physical storage structure. Okay, how the data is stored, those details need not be required in the conceptual schema. The conceptual schema only needs to know what type of data we can store. Okay, what data is stored in the database and the relationship among the data. Those things need to be concentrated in the conceptual level. Okay, that is why it is written here is that it hides the details of physical storage. Okay, physical storage implementation is hidden. It is hidden from the user. Okay, they are just dealing about the what all things describing the entities. What do you mean by entity? Entity means the real world object or the table name. The student is an entity. Okay, data type. Data, what do you mean by data type? The student entity, it is having three attributes: serial number, roll number, name, and marks. For roll number, it is having integer. For name, it is having character. So those things are called data types. Relationships. Relationship we have already explained yesterday, the previous session. What is that? Relationship is the association between two entities. We are having student table, and suppose we are having student table, and we are having marks table or department table. So student have relationship with the student is studying with student have association with the department, right? The student is studying in the department. Okay, so all those things is called a relationship. Now user operation, what all the operation the user can perform on this data. Suppose the user want to know the name of the student, you want to retrieve the name of the student. So what are the operation he has to performs? Okay, what all the operation can perform on the data? Okay, clear? Next is constraints. Constraints is the rules that we can provide. Suppose the user can give the details such as we can give that the mark column must not be kept empty, or the roll number must be the primary key of the table. Okay, so such concepts are called constraints. So all these things related to data is implemented in the conceptual level. Okay, so it is describing what type of data or what data it can store in the database and its relationship among the data. Okay, so it is highlighting the concepts in detail. The conceptual level represents what all things? All entities, their attributes, their relationship, the constraints on the data. Okay, constraints on the data. Semantic information about the data. What do you mean by semantic information? The rules that is implemented in the data, and the security and the integrity information. We can provide security in the information. Security can be provided in the particular data. Security means that an unauthorized person cannot access a particular data. Okay, suppose in a large table, student table, the student can view only the student name, its marks, their marks. They cannot view the phone number of the students. Okay, that will be hidden. Clear? So such type of security can be provided in the information. Clear? So all those concepts are implemented in the conceptual level. Okay, so internal level is completed. Second level is conceptual level. Okay, so internal level is describing about how we can store the data. Okay, the internal organization, physical storage structure. Okay, but in a conceptual level is saying what type of data we can store. Okay, what type of data we can store in the database. Clear? External level or view level. So as I said previously, that the external level or the view level uses the concept of which data model? High level or conceptual data model. Okay, so it uses the principle of high level or conceptual data model. So high level means what? High level or conceptual view data model means it is concentrating only on the user's perspective. Okay, what information a particular user required, only that information will be given to that particular user. So this external level, we can from the figure itself we can see that external level or the external view is actually connected with the end user. So end users are actually sitting near to this external level. So the required information that is required, the required information for the user is actually given in the required format by this external level. Suppose a student needs to know the marks, his marks. Okay, his marks of a particular subject. Okay, so this is the particular data he wants from the student database. So student database is having a huge database. It is having the all the student details of all student details of the entire college. Okay, entire college, and also the previously passed out students details also it is having. This particular person just want to know the marks of the computer subject. Okay, so this is the required data he wants. So such data can be retrieved from this database. Okay, and it will be given in the required formatted as prescribed by him. So this is the task of external level or the view level. Clear? So it describes a part of the database that a particular user group is interested and hides the rest of the database from the user. That is the concept I have just told. Okay, so whatever data the user wants, it will be given in that prescribed format. The rest of the data will be hidden from him. Okay, clear? The DBMS must transform a request specified on the external schema into a request against the conceptual schema, and then into the request on the internal schema for processing over to the stored database. Which means that if the user requests for a particular data, for example, he wants to pay, if that particular student wants the marks of mathematics subject in series 1, so he is giving the query, and this query will be accepted by this external level, and this will be in the format of external schema. Okay, so this external schema or the request that is accepted by this external level must transform that request into the format that is accepted by the conceptual level. So conceptual level will be having a particular format. It will be converted into that format. Okay, and it will be processed here. After that, the process information will be given in the format of the internal schema. Okay, so the internal schema will be having a certain format. It will be converted into that format. Okay, finally it will be processed and given to the format that is known by the database. Okay, from that it retrieve the information and need the required processing and reach the user. Okay, this is what it is performed here. Clear? So DBMS must transform a request specified on an external schema into the request against the conceptual schema. So whatever request the user is giving, it is given to the external schema, external level. So the external level will transform the request to the conceptual schema. Okay, the conceptual schema will transform the request to the internal schema. Okay, for processing over the stored database. Clear? That is what it is explained here. If the request is a database retrieval, the data extracted from the stored database must be reformatted to match the user's external view. Suppose the user is actually getting the database access and it is want to retrieve the information. What information is retrieving? The marks of his mathematics subject in series 1. So that is a database retrieval. Okay, so the request has reached here. Okay, the request has transformed from external level to conceptual view, from then to internal level. Okay, finally it reached the database. So that information is retrieved from the database. Okay, and it is transformed to the internal schema. The internal schema again transform it to the conceptual schema, and the conceptual schema will give it to the external view. And this external view will reformat that data in the format that the user wishes to view. Because suppose the user will be is requesting to view the report in a PDF format. Okay, PDF format. So it will be converted to that PDF format. So whatever format the user wishes to view, it will be converted to that format. Or he wishes to view the data in an Excel sheet. Okay, if it is so, it will be given in that particular format. Okay, so that is what it is saying, like that. If the request in the database retrieval, the data extracted from the stored database must be reformatted to match the user's external view. Okay, so the data must be reformatted in the view the user is expecting. Clear? So this is called external or view level. Clear? Now in this figure there is a concept called mapping. You have seen this mapping. Everywhere it is written mapping. So mapping is just the transforming the request. I have just told that the request from here, suppose a user is requesting for a particular data, it will reach here. So that request must be transformed to the format where the conceptual schema can read. Okay, so this is called mapping. Okay, the processing of transforming the request and results between the levels are called mapping. Okay, so from when the data is transferred from one level, or when the request is transferred from the one level to next level, it needs to be transformed to the format that level that the particular level understands. So external view will be understanding having a particular request. It needs to be transformed to the format where this conceptual schema can understand. The conceptual schema will transfer the data request to the internal schema into the format it understands. Okay, so that is called mapping. So that transformation is called mapping. The processing of transformation request and the results, also the requests, results also. The result must be reaching here, internal schema. It has to be converted to the conceptual schema point. Then it has to be converted to the external or view level format. Okay, so the request and the results, the transformation of both request and results between these levels is called mapping. Clear? So this mapping, in some cases, this mapping may be time consuming. Okay, at this level, this external view level, mapping is actually time consuming. Clear? Okay, so this is the concept called mapping. So this is the architecture of, this is the concept of 3 schema. So for summarizing the 3 schema architecture, you can say that the first level is the internal level. So it describes it describes how a data is stored. That means the internal storage structure and the file organizations are discussed here. Okay, how we can store a data in a database. All those details are actually concerned in the internal level. Next is the conceptual level. So it describes what type of data we can store. That is, we are having some data in the database. So we can, what type of data we can store, its data types, its relationship, what is the entity, and all those things are actually concerned in the conceptual level. Now the external level. So external level describes the type of data or what type of data the user needs. Those data will be given to the user in the prescribed format. Clear? So this is the main concept of three schema architecture. Clear?